Okay, second part of solving equations with properties. Okay, we're going to talk about what happens when we have variables on both sides of the equations. Now, it is going to take a couple more steps because you do have to do some switching. Okay, the idea is still the same. You still are trying to isolate the variable, meaning you're trying to get x by itself. So everything that is attached to the x needs to go away. Okay. The only way that you can do this, right? The only way to get x by itself is to make sure that all x's, everything that has an x, all the terms, are on the same side of the equation. Okay. So we have to combine them in order for there only to be, one term with an x so that we can actually solve it and get it by itself. Okay. So you're going to do this the same way as if you were moving numbers or constant terms around, right? You have a -4 here, so you would add 4 to both sides, or you have a +9 here, so you would subtract 9 from both sides. Okay. Please remember, if there is no sign in front of a number or a term, that sign or that term, rather, that number is automatically positive. Okay. So we need to move all of the x's to one side so that you can combine them, right? So that we can then keep solving the equation like we've been doing. Now, whichever one you choose to move, again, is not wrong. You choose. The only rule that you have on this, okay, is that you cannot move everything from one side. That's the only real basic rule. And technically you can even still do that. It means you're going to end up having a 0 and you're going to have to do more work. So what we want to just sort of keep in mind is don't get rid of everything from one side. Okay. So that basically means if you want to move the 3x by subtracting it and you want to move the 4 by adding it, you're not going to have anything left over here. It's going to be a 0. Okay. So you're not going to want to do that. If you choose to move the 3x, then you're going to want to choose to move the 9, right? You're going to want to pick one different thing from each side to add or subtract to move it over, right? Because if you end up with 0 on one side, and a lot of people, the only reason I'm going to even say that is there's a lot of people forget that there's a 0 there and they go straight to dividing and then all their signs are wrong. Okay. So don't get rid of everything from one side. Pick one thing from each side, one different thing from each side to move. Now, for me, I don't like dealing with negative x's if I can, right? So I would want to move the smaller of the two numbers that have an x on them, that actually have the term, just so that I don't end up with a negative. So like I said, that is a positive 2x. So I am going to subtract 2x from both sides. Okay, so that means I am using the subtraction property of equality. Right, and as we stated in the first video, if you are using the addition or subtraction property, your very next step is always combine like terms. Okay, so let's combine like terms and see what we have. On this side, on the left, I have 3x minus 2x. Well, 3 minus 2 is 1, so I have basically x. That minus 4 has not gone anywhere. It's still there. Okay, on the right side, well, 2x minus 2x is a 0 pair, so all I have left is 9. Okay, so not too bad. Again, now I have my equation down to where there is only one x, which means I can actually get that x by itself. All right, so I need to get rid of the minus 4. Okay, so the opposite of minus 4 is plus 4, so I'm going to use the addition property now. Okay, so then again, because I added or subtracted, I have to make sure I am combining like terms. Okay, so -4 plus 4 is 0, so that's a 0 pair gone, and then 9 plus 4 is 13. Again, my biggest problem with people taking everything off of one side, subtracting 2x and then subtracting 9, you end up with x minus 13 equals 0. And a lot of people will just stop and they'll think they're done because there's nothing else there. So we need to make sure that you're taking something different from each side. Okay, so don't try to get rid of everything on one side and get a 0. All right, so x equals 13. We have all of our steps, still doing the same operations, right? It's just now there's variables on both sides. All right, let's try another one. Okay, so same deal. First step is always original equation. Okay, so couple of choices. Again, we can go with the distributive property. There's nothing wrong with that because we have parentheses and we have the 3. We can also go with the division because that 3 is multiplying everything, right? Just like before. Remember the rule though, if you divide or multiply, you have to multiply everything or divide everything. So you will be dividing this side to get rid of the 3, and then you'll end up dividing the 5 and the 12 by 3, and you're going to end up with a fraction. That's okay. There's nothing wrong with it. You have calculators that will help you with fractions if you're struggling. If we do the distributive property, we won't have any fractions. So it's really your choice. In this case, I don't want to have 5 over 3x. So I'm not going to do the division first. I'm going to choose to use the distributive property. All right. So what do I get when I distribute? Gotta love technology. All right, I'm going to get 3x minus 12 equals 5x minus 12. Okay, I don't have to write simplify. I don't have to write combine like terms. Distributive property explains exactly what you're doing and what you're getting. Okay, so now back to I have to have all of my x's on one side so that I can actually, simplify it. I have to choose which x I want to move. And again, it doesn't matter. You can move either one. I just personally don't like to have negatives. I know some people are like, okay, always move the variable to the left and always move your constants to the right. You can do that as well. It's fine. I just don't like dealing with negatives, so I always choose to move the smaller number. So I am going to subtract 3x from both sides. Right, showing that I am doing the same step on both sides. So that is subtraction property of equality. And remember that we are subtracting. There's no symbol in front of either of the x's, so that means that they are both positive. So we have to subtract them to do the opposite. All right, once we add or subtract, we always combine like terms for the next step. So let's see what that's going to be. 3x minus 3x is a 0 pair. So I have negative 12. There is a minus there. It's got to come down with the 12. It belongs to it. And then 5x minus 3x is 2x. And then there's still a minus 12 here. Okay, so like I said before, I got rid of this 3x. So I go to the other side to move the constant. All right, that is a negative 12 or a minus 12. So I have to add 12 to both sides. All right, so I'm going to show that I'm adding 12 to both sides. All right, and then we're going to combine like terms, like we do every time we add or subtract. All right, so negative 12 plus 12 is 0. 2x, negative 12 plus 12 is also 0. Now, a lot of people will look at this and go, oh, there's no solution to this equation. There is a solution. 0 is an actual number that you can use, right? That is an actual number that you can get as a solution. We do want to go ahead and show the last step, though, because technically the x is still not by itself. It's been multiplied by 2. So we do actually have to do the division property of equality. Okay, so I'm going to show that I am dividing by 2 on both sides once my technology decides to agree with me. All right, equals 2x divided by 2. All right, so 0 divided by 2 is still 0. My answer, x equals 0 or 0 equals x, it's the same thing. That is actually allowed. Don't forget to put simplify since we divided. X equals 0 is an allowable number. You can graph it on a number line. You can graph it on a coordinate plane. It does exist. So, all right. So we do actually have two special cases where, if you were thinking that this was a no solution, we do have two special cases that I want to show you as far as what happens sometimes when you have variables on both sides. So two special situations. You can have something that's called infinite solutions, which basically means that any number that you substitute in for x, like x could be anything, will work. Then you have the case where there is no solution. And I'm going to work through both of these. I'm not going to write down the property steps, but I'm going to work through both of these so that you can see what happens. All right, so I'm going to go ahead and distribute the first one. All right, so 2x minus 6 equals 2x minus 6. And I'm going to subtract 2x from both sides. All right, and I'm going to get negative 6 equals negative 6. Take a look. Is that ever not going to be true? I mean, is there ever a time that negative 6 is not going to equal negative 6? No. So basically, this is something that always is going to be a true statement, which is why we call that infinite solutions. So if you end up with something like this, or you end up with 0 equals 0, or you end up with 2x equals 2x because you decided to add 6's to both sides first, that is always going to be a true statement. So that is considered an infinite solution. And you don't actually have to keep going from there. Now, the no solution type, again, I'm going to go ahead and distribute. And I'm going to subtract 3x from both sides. Again, I always start with the variables just because I want to get them moved first so that I can deal with starting to solve them. If technology does not want to be stubborn. There we go. All right, so what I'm going to end up with, why today? What I'm going to end up with is negative 4, there we go, equals 15. Because both of my sets of x's are 0 pairs, and they're going to both end up being 0 and being gone, so all you have left is the constants. So I don't even have a variable to solve for at this point. I didn't have a variable to solve for over here either, but notice that negative 6 is the exact same thing on both sides of the equals, right? Okay, well, I have negative 4 and 15. Unless you go and take a lot of higher math in college, that is not going to happen. That is never going to be a true statement where negative 4 equals 15. So that is why that is considered no solution, because it is not possible to happen. Okay. All right. So those are the two exceptions as far as having not just having one answer, but having either all answers or no answers at all. And we are done with variables on both sides. We've got one last thing that we do with properties, and that is inequalities, which we're going to get to in the next bit.